All right, Joe. Let's work through some of the homework. So arithmetic series. Let's start with the formulas that we're going to need that will probably come up. So a sub n, right, any term, or technically not any term. The sum, right, of the partial series is going to be, so this is arithmetic, so it's going to be so n divided by 2 times the first term plus the nth term. Another useful formula is going to be this right here. 2a sub 1, 2 times a sub 1 plus n minus 1 times the common difference. So these two, whichever one is handy at the time. So let's just start working through these. All right, number 10, find the partial sum of the first 10 terms, right? That's S sub 10. So the first 10 terms of an arithmetic series with a sub 1 is 4, and the difference is 5. Okay. So I think of the two, right? So let's kind of break down the two. For the first one, for this to be successful, there's a couple things we need to know. We need to know the first term and the nth term. In this case, S10. Well, we don't know what S sub 10 is, right? That's what we're looking for. So formula 1 is not ideal. Second formula, all you really need to know is just the first term and the common difference. And then whatever it is, like whatever the n value is. So I think number 2 here is going to be the beneficial one because n is equal to 10. Therefore, S sub 10, right? Just plugging in 10 for n. 10 over 2 times 2 times the first term, a sub 1. Well, in this case, a sub 1 is 4. So 2 times 4 plus n, which was 10 minus 1, times the common difference, which is 5. All right, so you got to be very careful if you're a calculator user that you're paying very close attention to parentheses and order of operations. So 10 divided by 2 is 5 times 2 times 4, which is 8, plus 10 minus 1, which is 9, times 5 is 45. So 8 plus 5, or 8 plus 45. So 5 and 3, so 53. 5 times 53. Which is going to be 5 times 3 is 15. Carry the 1, 25, 26. So if I add up the first 10 terms in an arithmetic series where the first term is 4 and it goes up by 5 every time. So 4, 9, 14, 19, ... If I add up the first 10 of those, it would be 265. Okay, number 11. Find the partial sum of the first 12. And here, so let's see. So a couple things. So n is going to be equal to 12, right? Because we're looking for the 12th one. I know a sub 1, the first term is 26. The common difference. So how do we get from one term to the next? Well, we're subtracting 2. Oh, we're subtracting 2. And we're subtracting 2. So minus 2. Minus 2 is the common difference. All right. Again, the second formula here is going to be the 1. Because we don't know what the 12th term is. I mean, technically, I guess I could keep writing them out if I wanted to and just write the 12th term but I feel like that's too much work. Let's just stick to the script, right? So n is going to be 12 divided by 2 times 2 times the first term, 26, plus 12 minus 1 times -2. Oh no, writing out the terms kind of looks a little bit better right now. Kind of looks a little bit better. All right, so this is going to be 6 times 26 times 2. So 52 plus 11 times -2, which would be -22. This ain't so bad. So 6 times 52 minus 22. So 50 minus 20 is going to be 30. Oh, this isn't bad at all. So 6 times 30, 180. 180. It's not bad. Can't be scared. Can't be scared of the math. Right. All right. Number 12. Find the sum of the first 10 terms. So right away, n is equal to 10 of an arithmetic sequence with an eighth term of 8.2. So a sub 8 is 8.2. And a common difference of 0.4. So common difference of 0.4. All right, so this one is there's really no way around this. So the eighth term, right, is going to be 8.2. So if the common difference is 4, I'm just going to subtract 0.4 from 8.2. So that means, so it's kind of like write this in reverse, right? So I'm going to need 8 terms for sure. So look, the way I'm doing it. So the eighth term is that if I subtract 0.4, 7.8, subtract 4, or 0.4, again 0.4, 0.4, 0.4 would be 5.8, and then 5.4. All right, so this was a sub 8, right? That's what they told us. So a sub 9 and then a sub 10. So we got, what do we got? Plus 0.4, so 8.6, and then 9.0. All right, this is a sub 1. This is a sub 10. All right, now maybe there's a better way of doing this, but I've already started. So I'm going to utilize the first formula. So we want the first 10. So n is equal to 10. So 10 over 2 times the first term plus the 10th term All right, just double checking the formula. So this is going to be 10 divided by 2 is 5. 5.4 plus 9. 14.4. Okay, multiply this up. 5 times 4 is 20. Carry the 2. Again, 20 plus 2. Carry the 2. 5, 6, 7. So 72. If you add up from a sub 1 to a sub 10. All right, number 13. An auditorium has 12 seats in the first row, 15 in the second, 18 in the third. If this pattern continues, what is the total number of seats in the first 8 rows? Okay, So if the first row has 12, and then the second row has 15, the third row has 18. If this continues, what will the sum of the first 8? So we want a sub 1 through 8. All right. So first off, 12 is a sub 1. And first 8 rows, therefore n is equal to 8. And the common difference we see is positive 3. Right, 12, 15, 18. Okay, so sum of the first 8 terms is going to be n, which is 8, divided by 2, times 2 times the first term, which is 12, plus n minus 1 times the, let's put some values in, n minus 1, so n in this case is 8, and then the common difference is 3. Okay, 8 divided by 2, 4. 12 times 2 is 24. 7 times 3 is 21. So 4 times 24 plus 21, 45. So 4 times 45 would be 50, 50, 50, 50. So 200 minus 5, 10, 15, 20, 180. First 8 terms would add up to first. So there'd be 180 seats in the first 8 rows if it started at 12 and went up by 3 every time. All right, 12. Find the indicated partial sum of each arithmetic series. All right, too easy. So S sub 10, we know that n is equal to 10. So this is going to be 2 times the first term, 4. Should I say 10 divided by 2 times 2 times the first term plus n minus 1 times the common difference. So 5, 2 times 4 is 8, plus 10 minus 1 is 9, times 5 is 45. So 8 plus 45, 5 and 3, 53. 5 times 53. 5 times 3 is 15, carry the 1, 25, 26. All right, B, we're looking for sum of the first 12. So n is equal to 12. All right, sum of the first 12 is going to be 12 divided by 2. 2 times the first term, which is 14, plus 12 minus 1 times the common difference. All right, plus 4, or positive 4, so times positive 4. So this is going to be 6. 2 times 14 is 28. Plus 12 minus 1 is 11. Times 4 is 44. So 6 times whatever 28 plus 44 is. So 44, 54, 64 plus 8. 72. 6 times 2 is 12. Carry the 1. 42 plus 1, 43. 432. Okay. These are going to get pretty serious. Our n equals 18 for C. So first 18 terms. All right, this number is going to be huge. I can already tell you. So S18 is equal to 18 divided by 2. 2 times 45 plus 18 minus 1 times the common difference. What's the common difference? Minus 4? Minus 4? Minus 4? Okay, so negative 4. 18 divided by 2 is 9. 2 times 45 is 90. Plus 17 times 4. Negative 4. So 4 times 7 is 28. Carry the 2. 4, 5, 6, 68. 9. All right, so 90 minus 68. What was that? 38? No. 22? 9 times 22? So 9 times 2 is 18. Carry the 1. 18, 19. 198. All right. A couple more. So we want the sum of the first 6. All right, so we're actually going up by 2. So I'm going to actually finish this one and do this one a different way. So 5, 7 plus 9 plus 11. So S sub 6, n equals 6, right? So this is going to be 6 divided by 2. First term plus the 11th term, or the 6th term, which is 11. So it's going to be 6 divided by 2 is 3. 11 plus 1 is 12. So 12 times 3. 12 times 4, 36. I used Formula 1 in that one, just FYI. You can either use like, we didn't have to use that. I could use another one, like the one that we've been using. But, you know, sometimes you gotta switch it up. All right. Same idea, except we're looking for the 10th term. So if you notice, these are the first odd numbers. 1, 3, 5, 7, 9, 11. So I'm just going to pick up where the last one left off. 7 plus 9 plus 11. That was 6. 7, 8, 9, 10. Right? Okay, so adding all these up, we can do S10. 6 divided by 2. No, this here is 10. N is equal to 10. So 10 divided by 2. 1 plus 17, 19. Sorry, hand was in the way. This is going to be 5 times 20, which is 100. Okay. So if this was, so if plus 19, right? Everything up to 19 was 12. No, it was 10. 11 would be 21. 12 would be 23. So if we do the same thing, right? N is equal to 12. So S12 is equal to 12 divided by 2, the first one plus the 12th one. So 6 times 24. Okay. 6 times 4 is 24. Carry the 2, 12, 13, 14. All right, 144. Okay, so part D is saying to compare the relationship between N and the sum of that place. So the relationship or the pattern, hopefully it's kind of obvious, right? Like we have to connect 6 to 36, 10 to 100, and 12 to 144. So n, whatever it is, will be n squared. That's the pattern. Right, so if I'm looking for, if it was the same pattern and I wanted the 13th terms, well then 13 squared would be 169. So that's the relationship between n and s sub n, right? If this was n and this was s sub n, right? The sum of the first nth terms. Okay, that's kind of interesting. All right, what's 14 talking about? Find the indicated partial sum of the arithmetic series 0 plus x plus 2 plus 2x plus 4 all the way up to the 10th one. So am I guessing that these are my answers to choose from? So 0, so if this continues, the x's are going up by 1 and the constants are going up by 2. So that would mean, well, we want to add all these up. All right, n is going to equal to 10, right? N is equal to 10. I don't know why, but I don't like this purple. Let's just use red. No, let's use green. All right, so if n is equal to 10, right? N is equal to 10. We'll take s sub 10, which is going to be 10 divided by 2 times 2 times the first term, which in this case is 0. It's kind of nice. Plus n minus 1, so 10 minus 1, times the common difference. So we added to 0. So in this case, what's the common difference? The common difference is going to be x plus 2. Right, because that got added to 0 to get to the second term. All right, so this is going to be 5. 2 times 0 is 0. That's nice. Plus 10 minus 1, which is 9, times x plus 2. Which if we distribute that, that's going to be 5 times 9x plus 18, which when we distribute the 5 is going to be 45x, so C right away. Plus is 5 times 18, 90. 5 times 8 is 40. Yeah, 90. All right. 45x plus 90. Kind of interesting. That was an interesting one for sure. Okay. A, B, C, and D. Okay, so I'm guessing this all revolves around this problem here. So 2 companies offer you a job. Company A offers you $40,000 first year salary with an annual raise of $1,500. Company B offers you $38,500 first year salary and an annual raise of $2,000. What would your salary be with Company A as you begin your 6th year? All right, yeah, this is a for sure a practical use of this problem here. So we're starting off, so A sub 1 is going to be 40K. the difference from year to year is 1,500, right? Because it's going up. It's increasing 1,500 a year every year. And we want to know, what would the salary be as you begin your 6th year? So n is equal to 6. Okay, so we got all right, so just note this isn't a series problem, right? We're not adding up every year. This is a sequence, a geometric sequence problem. Actually, were any of these? Oh, not geometric, arithmetic. So it's not an arithmetic series problem, it's an arithmetic sequence problem. So we're not adding them, we're just listing out what you're making the first year, right? So this is going to be, so a sub 6, that's what we're looking for. So n is equal to 6, right? So if we think back to the arithmetic sequence video, or the notes rather, the formula a sub n is going to be, or any term is going to be a sub 1 plus n minus 1 times the common difference. So it's very similar to the sum. So a sub 6 is equal to the first term, so 40,000, n minus 1, so 6 minus 1, which is 5, times 1,500. Okay, 1,500 times 5 is going to be, so 40,000 plus 15 times 5. So 5 times 5 is 25. Carry the 2, 5, 6, 7. So 75. So 47.5. So you would start the year off, if you get a $1,500 raise every year, that 6th year you're looking at 47.5. What would the salary be with company B? All right, so 38.5 is a sub 1. Common difference again is 15. N is equal to 6. So a sub 6 is equal to 38.5 plus 5 times 1,500. So 5 times 1,500, that doesn't change. 38.5 plus 7,500, which is 38, 39, 40, 41, 42, 43, 44, 45. 45.5 plus 5, 46. So in starting the 6th year, company A is looking a little bit better. Well, $1,500 a year. It's like slightly more than $100 more a month. Right, 1,500 more. Okay. C, what would your total earnings be with company after 5 years? All right, so again, the same problem, except we're looking for a sub 5 with all the calculations from A, right? So n would be 5. So it's the same formula, except n is equal to 5. That's really the only difference. So 40,000 plus 4, right? Because 5 minus 1 times 1,500, which is, so 2 times 1,500 would be 3. So this would be 6,000. So 46,000, that's what you would have starting the 5th year. Or, Oh, wait. Total earnings, bro. Okay, so this is a series question, right? Because now we're adding things up. Now we're adding things up. Okay. So if n is equal to 5, again, a sub 1 was 40,000. So this is going to be after 5 years. So s sub n, or s sub 5 rather, is equal to 5 divided by 2. That's unfortunate. 2 times a sub 1, so 40,000, plus n sub 1, or n minus 1, so 5 minus 1 is 4, times the common difference, 1,500. Right? Yeah, that's it. Okay. This is going to be 5 halves times 80,000 plus 6,000. So 5 halves times 86,000. All right, half of 86 is 43. So 43,000 times 5. Because that's what it would be. 5 halves, right? Divided by 2 times 5. So 86 divided by 3. 86 divided by 2 is 43. And now 43 times 5. 3 times 5 is 15. Carry the 1. 5 times 4 is 20. So 21. 3 zeros. So after 5 years with company A, you're taking to the bank about 215,000. Double checking that. 43 times 5. 15. Yeah. 21. Okay. The idea, the same thing, but now with the numbers from company B. So n is equal to 5. So again, 5 halves. 38.5 times 2. So it's 38 times 2. 40 and 40 would be 80 minus 4. 76 plus 1,000, 77. Right, 77,000, that's what 38.5 times 2 would be. Plus 4 times 1,500, we just said was 6,000. Okay, what's 76 plus 6? 80, 83? 83,000? So this would be 42 and a half. Right? 83 divided by 2. Is that true? No, it's not. So I don't have a calculator. I don't need one. So it's 41 and a half. 41 and a half, right? 40, 41 twice would be 42 or 82. And then plus 1,000, 83. All right. Times this by 5. This is easy. So 0, 0. 5 on 5 is 25. 5, 6, 7. 207,500. So after 5 years at company B, this is what you would make. So I'll let you decide. Is the extra money worth it? Okay. 16. So n is equal to 12. So s sub 12. 12 divided by 2 is 6. 2 times a sub 1. So 2 times 40. 80. Plus n minus 1. 11. Times the common difference. Oh, word. We are looking for the common difference. So D, we don't know. S12, I guess we could have read the problem. S sub 12 is already 744. All right, so this is just algebra. So if we distribute the 6, 8 times 6 is 48. Plus 66. D. All right, minus 480. Minus 480. $264. So 264 is equal to 66D. Divide both sides by 66. Oh man, you made me bring out a calculator. So 264 divided by 66. 4. I knew it was going to be an even number or a whole number. So here D is equal, the common difference is equal to 4. That one's kind of fun, going backwards. Reverse. All right, in an arithmetic series, a sub 1 is 47. A sub 7 is negative 13. Find D, common difference, and then the sum of the first 7. So common difference is going to be what we're looking for. So how do we want to go about doing this? Do we want to list them all out? Oh, we can't. We don't know what the common difference is. Let's see. Let's look at our formulas. What formulas do we have? The sum of the first 7. Okay. So we could use that. We could use formula number 1 for right now. Right, because the sum of the first nth terms is n divided by 2. A sub 1 plus a sub n. And in this case, if n is 7, right, we'll let n equal 7. So s sub 7 is going to equal 7 divided by 2, 47, plus negative 13, technically minus 13. So 7 halves is equal to 37, 34. Right, 37 minus 3, 34. All right, and then 7 halves. So 34 divided by 2 times 7. 34 divided by 2, 17. 17 times 7 is going to be 7 times 7 is 49. 7, 8, 9, 10, 11. 119. So S sub 7 is equal to 119. All right, we're going to use that to figure out what D is. So 119, right, S sub 7 is equal to N, which in this case is 7, halves, times 2 times the first term, so 2 times 47, plus N minus 1, 7 minus 1, 6, times the common difference, D, the thing we're looking for. Okay. What was 2 times 47? 87 plus 7, 94. Distributing that. All right, 94 times 2. No, 94 divided by 2 times 7. 329. Six divided by 2 is 3 times 7 is 21. D. And this is all equal to 119. Okay. 119 minus 329. So this is going to be negative 210 is equal to 21D. Divide both sides by 21. D is going to be negative 10. So common difference is negative 10. And S sub 7 is 119. So you had to find S sub 7 prior to finding the common difference. That's what happened there. Okay. 18. Another one just like it. So now we're looking for A sub 1. All right, A sub 1. How can we get there from A sub 9? Probably brute force. 0.49 times. Right, A sub 8 would be 9.4. No, that's not correct. It would be 0.4. This would be 8.64. This would be 8.24. Is there a better way than this? That's the question. Don't know. 7.84. There's bound to be a better way, but I'm already almost there. So if you can come up with a better way, good for you. All right, so, right, because A sub 1 and the series adding up the first 9 terms, well, you need to know A sub 1. So really, A sub 1 is the first thing we have to get to. What other formula do we have? Right here, A sub 1, but we don't know what S sub 7 was. Or actually, we had to find S sub 7. We didn't know. Like there's too many missing variables. But at least this way, we know what A sub 1 is. Right, we know what A sub 1 is. So now, finding S sub 9, where n is equal to 9. So 9/2 times 2 times 6.24 plus n minus 1, 8, times the difference of 0.4. Okay. So 9/2, 12.48 plus 0.32, right? No, 3.2. All right, this is going to be, again, 9 halves. 0.48 plus 3.2, so, or 12.48 plus 3.2, so 15.5. It's not bad. Times, divided by 2 times 9. So 7.5, 7.75. Times 9. 9 times 5 is 45. Here are the 4. 63. 7. 63. 69. And then 2. 69.75. This is S sub 9. So the sum of the first 9 terms. That almost seems incorrect. It'll be fine. All right. Multiple choice. I like it. Sum of these. Oh, there's more. All right, so the first prize of a contest is $500. Second prize is $450. Third prize $400, so on and so forth. How many prizes will be awarded if the last prize is $100? So $500, $450, $400, and so on until we get to $100. So we're looking for the value of n. The value of n. How many n's are there? Okay, well, I mean, it's decreasing by 50. Right, those are the ones that are missing. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 prizes. How much money will be given out? Okay, so we want the sum of S sub 9. So n is equal to 9, basically, right? Because there's 9 prizes. There's 9 slots. So 9 halves. So, you know, the common difference is negative 50. So this is going to be 2 times the first term plus n minus 1. So 9 minus 1, which is 8, times negative 50. Okay. 9 halves. 1,000 minus 8 times 5 is 40. So minus 400. All right, so then this is going to be 9 halves, 600. So half of 600 is 300 times 9. So 2700. $2,700 total was given out. Okay. Find the sum of these. Okay, so I think here we'll use the fact that a sub n in a sequence is a sub 1 plus n minus 1 times the common difference. Man, I feel like this probably would have been the answer to number 18. Now that I'm thinking about it, it's crazy how it comes to you all of a sudden. Yeah, 18. Instead of making the list, we could have used the formula that we're about to use right now. All right, so common difference. So a sub n, which is 193, right? Because it's the last one, is going to be equal to the first term plus n minus 1, common difference of plus 7 plus 5, 12, plus 12. Yeah, so 12 is the common difference. So this would have been 13 plus distribute 12n minus 12. Oh, that's nice. Combining the like terms, 12 minus 13 minus 12 is 1. Minus 1, minus 1. So 192 divided by 12. That's got to be a whole number. Right? So n is equal to, well, 144. Right, is 12. 156. No, plus 12 would be what? 144. This is 192. So 144 plus 12. 144 plus 12. 154, 156. 168. 180. 192. 16. N is equal to 16. So what does that tell us? That tells us that n has to be 16. So there's 16 from 13 to 193. There's 16 terms. So the sum of the first 16, which in this case all of them, is going to be, so n is equal to 16, right? That's what this is meaning. So 16 over 2. 2 times the first term plus n minus 1. So 16 minus 1, which is 15. Common difference, we said, was 12. All right, doing some math here. This is going to be 8. 2 times 13 is 26. 15 times 12. Well, we know that 16 times 12 is 192. So 15 times 12 would be 180, which is equal to 206. 8 times 206. So the sum of the first 16 is going to be 8 times 6 is 48. Carry the 4. 1648. 1648. Yeah, so this formula for sequences, that's what came in clutch right now. That's what we could have used down here. Now that I think about it, right? Because you would have used a sub 9, which is 9.4, is equal to a sub 1, right? Which we don't know, plus n minus 1. N in this case is going to be 9. 9 minus 1 would be 8, times the common difference of 0.4. So 8 times 0.4 is 3.2. So when you subtract 3.2, you're going to get 9.12. No. Is it 9.12? Maybe I was wrong. That's not it. That ain't it. A sub 9, 9.44. A sub 1, we don't know. Plus n minus 1. So 9 minus 1, which is 8. Times the common difference of 0.4. Oh, I see my error. 3.2, bro. 3.2. So 4, 2, 6. 6.24. And that's exactly what A sub 1 is. So that's interesting for sure. All right. 21. Last two. Right under an hour. Let's go. Find the sum of the first 150 natural numbers. Okay, so natural numbers are 1, 2, 3, 4, ... up to 150. So n is equal to 150. So the sum of the first 150 terms is going to be 150 divided by 2 times the first 2 times the first term plus 150, right, n minus 1, so 149, times the common difference of 1, right? Common difference is just 1 because it's going up by 1 every time. Okay, this is going to be 150 divided by 2, which is 75. 2 times 1 is 2 plus 149. This is really 75 times 151. Calculator time for sure. 11,325. Okay. All right, last one. A store puts boxes of canned goods into a stack display. There are 20 boxes in the bottom layer. Each layer has 2 fewer boxes than the layer below it. Okay, so there are 5. How many boxes are in the display? Explain your answer. Okay, well, I'll just work out the answer and the explanation is in that. So, if you have 20 boxes, right? And then you have 2 less. And then 2 less. And then 2 less, right? Like this pattern keeps going. So you have 20, 18, 16, 14, 12. There are 5 layers of boxes. Explain how many boxes are in the display. All right, so we just add these up. I mean, you could just add these up using just traditional math methods. But let's stick to what we've been doing, right? The sum of the first 5. So n is equal to 5. N is equal to 5. Common difference is going to be -2. So 5 halves. 2 times the first term plus n minus 1 times the common difference. 5 halves. So 2 times 20 is 40 minus 8, which is 5 halves times 32. So half of 32 divided by 2 times 5. So half of 32 is 16. So 5 times 16. 5 times 6 is 30. Carry the 3. 80. So there are 80 boxes total. Okay. I explained my answer. All right, man. Good luck. Right at 1 hour.